Hello, everybody. My name is Andrei Farcasiu, and I'm a master's student from Carleton University in Ottawa, Canada. And today I'm here to present a 3-minute summary of my master's thesis where I'm devising a novel AI-assisted discontinuum-based computational modeling strategy. So, my work revolves around discontinuum-based analyses. And these is where I employ the discrete element method to simulate the mechanical behavior of individual masonry bricks found within unreinforced masonry structures. So the bricks are modeled using the simplified micromodeling method, where brick and mortar assemblies are represented as simplified blocks, with zero thickness interfaces. And the bonds are represented as subcontacts, where their behavior is simulated using a constitutive model, such as an elasto-softening one that my supervisor developed, which considers tensile strength, compressive strength, shear moduli, cohesion and friction, et cetera. And then, with the model prepared, it is then succumbed to, under external loading, either through vertical or lateral as well. And usually, in my research, I perform pushover analyses, where I have my model, and then I apply a load, and then I use it to determine its nominal load capacity as well as its associated failure mechanisms. But one of the major problems with executing this simulation method is the strenuous and time-consuming efforts required to make these analytical models, as you have to model them brick by brick. And also, in addition, most of these models in the literature neglect pre-existing damages, where if you do not consider pre-existing damages, you will provide inaccurate results with regards to its current structural integrity. Therefore, my thesis, My thesis proposes a complete workflow which incorporates several convolutional neural networks to detect and segment both bricks and cracks. So, for example, I import a photo from photogrammetry or post-processing of photographs. Then I train a YOLO model to detect bricks, and then I'll also detect cracks. And then afterwards, I input them into modeling algorithms, like for example this one, developed by my colleague Peter Griesbach, where we automatically create the simplified masonry blocks by overlaying a grid on top of the segmentation masks and assigning each grid cell with a certain brick depending on the color that is within the cell. And then similarly, for the cracks, I use a skeletonization-based algorithm which converts the crack masks into simplified vector lines, which I am using to sort of pinpoint which subcontacts are supposed to display dry joint behavior, where there is no cohesion and tensile strength. Then lastly, with everything prepared, I apply my lateral load, and
Your time is up.
that was pretty much it.